Today, we are going to simplify radicals. In the last lesson, we learned how to use the Pythagorean theorem to find the measures of right triangles, using a squared plus b squared equals c squared. But what if the last number isn't a perfect square? That's why today we're going to learn how to simplify radical expressions. Woo! A radical expression is one that contains a radical, or one of these. A radicand is the number inside the radical, in this instance the 5. A radical expression is simplified if all of the following are true. A radicand has no perfect square, the radicand contains no fractions, and no radicals appear in the denominator. So examples of unsimplified radical expressions would be 3 root 12, because 12 can be factored further into 4 and 3. Root x over 2 is unsimplified because the radicand, or the x over 2, is a fraction. And in the last one, a radical appears in the denominator over the 7. We can simplify radical expressions using multiplication and division properties of square roots. The multiplication property of square roots says that when a is greater than or equal to 0 and b is greater than or equal to 0, the square root of ab is equal to the square root of a times the square root of b. So let's look at the example, the square root of 48. 48 has many different factors. We have 2 and 24. We have 6 and 8, and 16 and 3. However, there is only one set of factors that contains a perfect square, and that is 16 and 3. Therefore, the square root of 48 can be broken down into the square root of 16 times the square root of 3. And then we know that square root of 16 is 4, so we have 4 root 3. Bam! Let's try another one by removing perfect square factors. So what is the simplified form of 160? Well, first we need to look at the factors of 160. We have 16 and 10, 2 and 80, 4 and 40, and 8 and 20. But as you notice, we have two sets of factors with a perfect square. We have 16 and 4. So which one do we choose? Well, we always want to go with the biggest perfect square that we have, which in this case is 16. So our square root of 160 turns into the square root of 16 times the square root of 10. Now we know that the square root of 16 is simply 4, and since 10 doesn't have any more square root factors, we leave it as the square root of 10. Now we have to solve radical expressions with variables. So we have to remember our exponent rules. A variable with an even exponent is a perfect square. For example, the square root of x squared is x. The square root of x to the 8th is x to the 4th. The square root of x to the 10th is x to the 5th, and so on. Now, a variable with an odd exponent is the product of a perfect square and a variable. Don't freak out yet. Okay, so if we have x to the 5th, the square root is x to the 4th times x to the 1st. Let's look at this problem. The square root of 54 n to the 7th. So our first step is to find the factors of 54, which are 2 and 27, 3 and 18, and 9 and 6. And if we look at these factors, the factors with the greatest perfect square is 9 and 6, simply for 9. Now we use the multiplication property of square roots to turn 54n to the 7th into the square root of 9n to the 6th times 6n. I know you may be asking what happened to n to the 7th. Well, remember that we have to break up the n to the 7th into n to the 6th times n, because according to our rules of exponents, remember that when you are multiplying variables with exponents, you simply add the exponents. So if we have n to the 6th times n to the 1st, 6 plus 1 gives us 7. Now we simplify both of these expressions. The square root of 9 is 3, and the square root of n to the 6th is n to the 3. If you're confused on how 9n to the 6th became 3n to the 3rd, please look at the diagram on the left. Now, since we can't simplify 3n cubed anymore, or root 6n, we simply leave it as 3n cubed times the square root of 6n. Now we can use the multiplication property of square roots to write the square root of a times the square root of b equals the square root of ab. So basically going backwards. So in the problem 2 root 7t times 3 root 14t squared, our first step is to multiply the whole numbers 2 and 3. 2 times 3 gives us 6, and then we use the multiplication property of square roots to write 7t times 14t squared. Now all we have left is to simplify under the radical symbol. So we have 6 root 7 times 14 is 98, and t times t squared is t cubed. We're not done yet, but thankfully we already know how to simplify these kinds of problems because we just learned it. Our first step is to find the perfect square factors of 98. 2 and 49 are factors of 98, and 49 also happens to be a perfect square. So step 2 is to rewrite the problem using the factors. So we have 6 root 49t squared because we need to break up our t cubed into a perfect square times 2t. Now we use the multiplication property of square roots to rewrite the problem as 6 root 49t squared times root 2t. Now we pull out our perfect squares from root 49t squared. We pull out 7t because the square root of 49 is 7 and the square root of t squared is t. So now we have 6 times 7t root 2t, since we couldn't simplify it any further, and 6 times 7t gives us 42t root 2t. And that is our answer. Now let's look at the division property of square roots. When a is greater than or equal to 0 and b is greater than or equal to 0, the square root of a over b is equal to the square root of a over the square root of b. For example, if we have the square root of 36 over 49, this is like saying the square root of 36 over the square root of 49. And the square root of 36 is 6, and the square root of 49 is 7. Here's another example. Square root of 64 over 49 is equal to the square root of 64 over the square root of 49. Square root of 64 is 8, and the square root of 49 is 7. We can also use the division property of square roots to solve radical problems with variables. Let's look at the example 8x cubed over 50x. Our first step is to reduce as much as we can. So we can reduce each numerator and denominator by 2x, which will give us the square root of 4x squared over 25. Don't forget that when you're dividing numbers with exponents, you have to subtract the exponents. Now we'll use the division property of square roots to break this problem up a little bit. So we will turn it into the square root of 4x squared over the square root of 25. Now this looks a little more manageable. Now all we do is simplify. The square root of 4 is 2, and the square root of x squared is x, and the square root of 25 is 5. Lastly, when a radicand in a denominator isn't perfect square, you may need to rationalize it to remove the radicals, since we can't have any in the denominator. To do this, you simply multiply the numerator and denominator by the same radical expression. Let's look at the problem root 3 over root 7. So, all we do is we multiply the denominator by root 7 and the numerator by root 7. Now this gives us, root 7 times root 7 is simply 7, and root 3 times root 7 is none other than root 21 over 7. Let's try one more problem. Let's look at root 7 over root 8n. Our first step is to simplify 8n by finding its perfect square factors. Factors of 8 are 4 and 2, and 4 is a perfect square. So, step 2, according to the multiplication property of square roots, we break root 8n into root 4 times root 2n. Now, step 3, we simplify. Square root of 4 is equal to 2, and we can't simplify square root of 2n any further, so we keep it as 2n. So now we have root 7 over 2 times root 2n. Now we still have to rationalize the denominator. So we multiply the top and bottom by root 2n, because when you multiply the square root of something by itself, it equals itself. So if you have root 2n times root 2n, it's just 2n. And we multiply the top by root 2n also, because whatever you have to do to one side, you have to do to the other. So 2 times 2n gives you 4n, and root 7 times root 2n gives you root 14n.